Hi everyone. So I'm Derek Keats, one of the co-founders of Learn the Birds, and this little video was prompted by a question that was asked when I did my last webinar on Learn the Birds. And the question was, how do birds see color? And so I'm going to look at, make a little short presentation on how birds see color, and specifically how birds and humans differ in how they see color and how little we understand how birds actually see color. So we know that color is important to birds because they live in a world of color, and birds use color for all sorts of purposes. But a lot of it is for the purpose of signaling to other birds or for hiding themselves from potential predators. But how do they see color? Do they see it the same way we do? The answer is we really don't know. So let's look at what color is, first of all. Color is a tiny little bit of the electromagnetic spectrum that our eyes can detect, and birds' eyes can detect, and most other animals' eyes can detect. And it's a relatively narrow band within the whole broad electromagnetic spectrum. And it's not surprising, really, when we have the sun, our star, bathing us in electromagnetic radiation in this band that actually penetrates through the atmosphere into onto the ground level where we live. So light, that little narrow band, goes from just above infrared up into deep purple and then ultraviolet that we can't see. And human vision really is from dark red up to dark purple, but not into the ultraviolet on the upper end, and not into the infrared on the lower end. And we actually have three kinds of cones in our eyes, which are the structures that in our retinas that detect color. And we detect red, we detect green, and we detect blue. And a simplified version of this is we detect a range of red light, a range of green light, and a range of blue light. This is, as I said, is highly simplified. But because we see these three colors, we said to be trichromatic, three colors, trichromatic. So we see red, green, and blue, and actually, the actual reality is more like this. We have a peak in the blue, a peak in the green, and an overlapping peak in the red, which is our short, medium, and long wavelength cones in our eyes. And birds have the same structure of cones. So they also see these same three peaks of color. But birds also see into ultraviolet, which we completely can't see. And so as a consequence of that, they're said to be tetrachromatic, four colors. Tetra, four, chromatic colors. So birds are tetrachromatic. Now, what might the impact of that be to birds and how they see or perceive color? So as I said, with our trichromatic vision, we see red, green, and blue. And all the other colors that we see are a consequence of a mix of those three, with an even mix of red and green giving us yellow, green and blue giving us cyan, blue and red giving us magenta. And so every color we see is really just a consequence of the differing influence of the quantity of red, green, and blue light that is entering our eyes and being perceived by our cones. Now, if we take a bird like this red-headed weaver, and we see it like this with our normal RGB vision, with all this beautiful red color, and if we're missing one of those colors, such as the red, for example, we see a very different looking bird. So missing that one color of perception in our cones gives us a completely different colored view of the bird. And in fact, we have a name for that. It's color blindness, right? So if you're tetrachromatic, as a bird would be, what would you see? You actually have another entire unimaginable set of colors that could conceivably arise out of having this extra place in the color spectrum or in the light spectrum that you can detect. What would it look like? So would our bird look something like this to us and that to a tetrachromatic bird? We don't know. And this is, of course, complete fiction because we can't imagine how it would be to have not just RGB, but RGB and UV, because we can't see it, so we have no idea what it would look like. We don't have any idea how it would be perceived. We just simply have no idea. But we do know that birds see into the ultraviolet, and there's even nuances there that I'm not going to talk about. So this is a blue tit, a common bird in Europe. And imagine this is a male, but the males and females to our eyes look exactly identical. We can't really tell them apart. They just look the same. But we know that in ultraviolet light, the female has this pale area of the crown that shows up in ultraviolet light. And males have no problem telling the female, and females have no problem telling the male. So potentially the ultraviolet light is playing a role there in discrimination between the sexes. But how does it actually appear to the bird? We don't know. We have no idea. Then there's how we appear to the birds. When I go out trying to photograph birds, I always have my camouflage shirt on, my camouflage hat on, and camouflage on my camera lens. And I think that the bird doesn't see me. But I have no clue how my clothing, my hat, the camo cover on my lens is actually seen by the bird, because I don't know how much UV light it is reflecting. And on a bright day, there's plenty of UV light around. Perhaps to the bird, I look like this. Or perhaps to the bird, I look like this. And meanwhile, I think I'm perfectly camouflaged. And the bird sees me standing out like a sore thumb. So the thing is, how do the birds see us? And how do the birds see and perceive things in ultraviolet when they have that extra capability? We have no idea. We don't know. We simply don't know. But we know it's there. And we know that birds don't see things the same way that we see them. They do see the RGB colors, but they see in addition the UV colors. And the consequence of this and how it's perceived in the bird is not something we can know. So that's just a quick overview of how birds see color from my perspective. Maybe you have a different perspective. Feel free to leave your comments. Cheers. Bye.